Okay, so we left here on last week on topic 1.4 from Unit 3. So here are the rest of the notes for this. So when we're talking about our electrical circuits, we have our series and our parallel circuits, which do have a different formula. So with our series circuit, remember there's only one path for the following charges to follow. So your charges always go from a negative to a positive direction. And again, that's just because of the flow of electrons. So the formula that we're going to be using is that the resistance total is going to be the resistance from your first resistor, your second resistor, your third, etc. So let's look at the first example. What is the total resistance in a circuit if it contains 3 resistors in a series with values of 2 ohms, 4 ohms, and 8 ohms? So really all you're doing is substituting this information into your formula. So your R total, R1, R2, R3. So 2 plus 4 plus 8 to give you 14 ohms. Now, in a parallel circuit, remember there's multiple pathways to follow through. So what's happening is that all the components have the same voltage across them. So when a second pathway is added, twice the current is able to flow, meaning that resistance will be half as much. So it's an inverse function. So basically, R1 over R1 total is 1 over R total is 1 over R1 plus 1 over R2 plus 1 over R3. So if you'll actually look at the series formula, it is the complete inverse of that. So how you would put this into your calculator. Okay, let's look at an example. So if we have the same number of resistance, but in a parallel circuit versus a series circuit, instead of adding 2, 4, and 8, we take the inverse of them. So you would take 1 over 2 plus 1 over 4 plus 1 over 8. So what happens is when you get this number, you get 0.875, but that's 1 over the R total. So in order to turn that into a, to solve for R, you take the inverse. So let's figure out how to do that in here. Okay, so remember brackets are your best friends. So 1 divided by 2 plus 1 divided by 4 plus 1 divided by 8, and then you get your 0.875. So to get the inverse of this function, you just take the x to the -1, which essentially takes the inverse of it. Okay, you could also just type that in. So 1 divided by 0.875. You'll find that you get the same answer. So our answer with 3 significant digits is 1.14 ohms. Now, the total resistance in a parallel circuit is 6 ohms. If there are 2 resistors and one of them has a value of 8 ohms, what is the value of the other resistor? So in this situation, we're actually solving for an unknown resistance. So we have our total, which is 6. And then again, our other information that was given to us was 8. So what we're going to do is we're going to manipulate our equation to have x by itself. So we're going to subtract 1 over 8 from both sides. So we're bringing it over here. So 1 over 6 subtract 1 over 8 equals 1 over x. So 1 over 6, okay, 1 over 6 subtract 1 over 8, okay, oops, there we go. Gives us a value of 0.0417 over x, and again, then we just take the inverse of that number, and then we get our answer, and our answer is 24 ohms. So because we have 2 significant digits here, we just have 24. We don't have a decimal. Okay. So 2 resistors with values of 6 and 3 are connected in parallel in a circuit. They have a power supply of 15 volts. So draw a schematic diagram of this circuit. So again, we have 2 resistors and it's parallel. So that's why we have the alternate pathways here. Now, we have our 15 volts as our power supply. So then we have a 6 ohm resistor in one part of the circuit and then a 3 ohm resistor in the other part of the circuit. So what's the total resistance in this circuit? So because it's a parallel circuit, we're going to use the inverse function or the parallel the formula for the parallel circuit. So again, 1 over R total is 1 over 6 plus 1 over 3. So 1 over R total, 1 over 6 plus 1 over 3 is 0.5. When you take the inverse of 0.5, you get 2 ohms. And again, 2 significant digits. What is the total current in this circuit? So I equals V over R. So our voltage is 15 volts and our resistance is 20 volts per amp, again, or ohms. And what you get is 7.5 amps as your answer. So that is the total current in this circuit. So for practice problems, 381, number 36 and 37, again, you can work on those questions. Just email me for the answers. And again, just to summarize our different formulas with our voltages and our resistance. So again, the difference between your current, you're calculating in a series or parallel. So again, series, we're just basically adding them up. Whereas in a parallel, we're taking the inverse function for our resistance. And again, you can work on practice problems 383, number 38 as well.